Hi there, I welcome you back to this class. In this class, I'm going to discuss about the types and models of GIS data. So if you have not watched the previous video, I would entreat that you watch the video because what I'm doing is to build a story from the beginning of video one to whatever we get to. So please watch that video. But if you've watched that video, you would see that this image is not new. Now, when we talk about types of GIS data, I've just separated, we've already talked about it in the previous video, just that perhaps you did not recognize that. But now I have added titles to them for you to see what they are. Now, the information that we already have, the one we've already been typing in Excel and using that to do scatter plot, to do histogram, bar charts and stuff, is what we call the attribute or non-spatial data. And by non-spatial data, I've explained that it means that it doesn't have any spatial information. Now, the information that we are talking about that is missing is the spatial information. That's the spatial data. Now, the question is, how do we capture this spatial data? And how do you even know when it is in your data? So I'm going to talk about the GIS data models as well. And GIS data models actually is a model that discuss how we capture data, different types of data. So before we do that, let me draw this background. So there are several informations we have in our on the surface of the earth. There are several informations that different organizations, different entities are working on. But some of these informations are discrete. They are informations that we can actually count. We can tell the beginning and the end. We can be very concrete and very specific about. Now, this data can be, they can actually stand on their own. They are quite independent. So this example, I'm using drops of water. If we open the tap such that it drops one at a time, we can count the number of drops and say we have 10 drops of water. However, there are some informations that do not have, that we cannot really count. We cannot really tell when they began and when they end. We can only see that there has been much information there. Now, this is a continuous data. This could be our height. This could be uh, our weight. This could be temperature. This could be uh, the length or any other thing. It could be uh, air pollution. So we do have informations that are not discrete. That is difficult for us to be able to confidently and conveniently say exactly what it is, but we can only relate it to one thing or the other, or sometimes we relate it to itself. So we look at maybe my weight today and compare it to my weight yesterday, but it is quite difficult for us to be able to be to be that concrete about it. We can also talk about the air pollution. You can only talk about the air pollution at one place and the air pollution at another place. This can you can only tell how much pollutant is there by measuring the difference between the two places, because there's always some sort of uncertainty in there. And so if we look at the example I have here, I have, if you open the tap big, we cannot tell how many drops of water make this tap. Okay, so that's basically one of the things that I want to draw our attention to. So that brings us to the GIS data models. In GIS, we have two basic data models. One we call the vector data model, the other one we call the raster data model. Now, the vector data model is designed to store discrete information, the one we just talked about. The raster data model is designed to store continuous information, which we've just talked about. I'm going to take these ones one at a time and try to explain. Now, we'll take the vector data model first. Now, if you look at the vector data model, it captures informations as points, as lines, or as polygons. It actually calculates or it actually captures the x and the y locations or the x and the y intersections of places and use that as the location of an information. And so you would you would find x and y, and the series of the x and y can connect together to be a line, and the series of the x and y, if they enclose itself, it ends up becoming a polygon. Now we do represent features like road, pipeline, or power lines as a line. We try to capture features such as buildings, plots of land as polygons because they actually enclose each other. And we do have informations like uh, the locations of wells, informations like let's say traffic lights. We have some informations like maybe locations of trash bin or trash can. These can be represented as points. So in the vector data model, we are saying that informations are captured as either line, point, or polygon, depending on how the information looks on the surface of the earth. So when we take road, power lines, we would call it or we'll capture it as a line. When we take discrete informations where we know exactly where it is, like the well, like locations of sample communities or like locations of trash cans, we would be able to identify exactly where they are, and so we'll have their these data captured as points. And then when we have if data or when we have feature on the earth that encloses each other, we capture them as a polygon. Within the vector data model, there are two types of vector data models. Within the vector data model, we have what we call the spaghetti model, and then we have what we call the topological model. Now, don't worry about the big English. I will try to explain this. Now, in our society, things are related to the other. Things are connected to the other. The building that is situated close to the park could be the office that manages the park. The bin that is placed in front of a house could be a bin that belongs to the house in whose entrance it is placed. In the vector data model, when we capture this data, sometimes we capture the data without including the information regarding the connections, the relationships that would exist between them. And so if you take a road, for instance, you have a road and one route would lead you, you have a destination and origin, but there are several routes that can lead you to your destination. However, if you take one route and you miss your way, if the data was captured without the relationship between the various roads, you wouldn't find how you find yourself back. So a practical example, if you ever use Google Maps and you try to use the Google Maps direction, sometimes Google Maps gives you direction. And if you are new to using Google Maps, you would always somehow miss the direction the map is giving you. And so you either turn too early or you bypass where you're supposed to turn. Now, when you do that, what the Google Map does is that it recalculates and tries to reroute you to still get you to your destination. Now, the question is, how did the map know that if you miss this line, that other road is also going to lead you to the destination? And that's what we mean by the relationship or the relation between the various things that exist. So buildings has their own relations, points have their own relations. Everything on the first surface of the earth is related to something. Now, if we capture the data without bringing this relationship, we call it the spaghetti model. The data is captured as independent entities. They do not have any relations. They are captured as just objects lying in space. And when we look at one, we cannot really tell how it is related to the next thing that is close to it. If the data has the information about the relations, then the data is using what we call the topological data model. So with the topological data model, we get to know the relationship between one entity or one object and the other. And so we can be able to do a lot with that, and we can be able to also understand how things actually interplay in space. So that is the vector data model. The vector data model is one data model under a GIS data. And under it, there are two models, the spaghetti model and the topological model. Now we talk about the raster data model. We've already talked about continuous data, and so you know information concerning air temperature, sometimes even vegetation. If you look at this image, we do not really know. It is difficult to know where one tree starts and where that one of them ends because they kind of ooze into each other. If you find grass, you cannot tell the individual grass and capture their locations because they are almost everywhere. Temperature, you cannot really tell where the temperature of 2 degrees starts and where it ends, and when the next negative maybe 2 or -1 temperature starts. So it is quite difficult to do that. So what we do is that we capture this as a space, and we only tell the intensity. It's a relational information. We try to find out how much more is here than the previous place and how much more is here than probably the next place. And so the raster data model captures data in a form of a cell. So this whole area can be captured as an area like this, but it will be divided into cells with a specific size. And then the whatever we are measuring, if it is air quality, if it is air pollution, we measure the air pollution in each of these cells. And each of these cells would have their own value that is representing the air quality or the air measure within the space. Now these values are then assigned with a color, which is representing their form of intensity. It is telling us how much of it is at that point or at that place. And so this image you are seeing is an example of this concept. So it is the size of the raster would make you see the elements as you see in this picture. Now this is assumed that it has been zoomed in, so you can see each of the cell has actually a value. The same thing happens to any satellite image that you see. Behind them are a cell with values, and these cells are actually um, more like a grid, which has a space, and then there are the individual cells in there, and then they have values. So this is GIS data types and GIS data models. I hope this video has been clear enough. I hope I've been able to explain in this class what a GIS data is, the types of GIS data, what GIS data model is, the types of GIS data model, and if there is any sub-model. I have also tried to explain this. You would be able to get more experience when you join the practical class that we organize. If you want to have a practical hands-on, 100% hands-on, then you sign up in the link in the description. There would be information on how you can sign up to one-on-one GIS training. where we treat you as you. We deal with you as an individual, and we teach you according to the way you absorb and according to the way you want to receive the information. So you can have a very strong foundation and build your career. Until then, in the next video, I will talk to you about coordinate system. I will try to explain this data that we are saying we are capturing. How do we even know where it is coming from? Because it's quite difficult for us to. It's easy to say we have captured them as X and Y. What is the X? What is the Y? How do they even work? How do we know where on earth something is coming from? That's what we're going to do with the coordinate system. And I hope to see you there, and I wish you all the best.